So we talked about last class how we're going to learn how to do the growth accounting method developed by Kehoe and Prescott. And you start from an aggregate Cobb-Douglas production function, which we talked about. You can rewrite GDP per working age person into a term that's related to the total factor productivity, and a term that's related to the capital output ratio, and a term that's related to employment. So if you have hours data, then this would be like hours worked per working age person. If you don't have hours data, then you can use employment, and this would just be the employment rate. Okay. So last class we talked about how using data on investment and GDP, we could use the perpetual inventory method to construct the capital series. And we talked about two different ways that we can initialize the capital stock, right? And so one was using the fact that the capital to output ratios are relatively stable over time. So you initialize the first period's capital to be equal to the average of that figure over the next 10 years. An alternative way to initialize the capital stock was to use the fact that the capital growth rates, the aggregate capital growth rates, should be pretty stable over time. So you use the average growth rate over the next 10 years to pin down the first period's capital stock. Okay, so we talked about this last class. Okay, so now that we have the GDP data, now that we have employment, or if you have hours, that works even better. But if you have employment data, and because we've now constructed the series for capital, we can simply compute the solar residual that gives us this TFP, right? So for that, you need some value for alpha. There's ways that you can calculate alpha country by country and over time. We're just going to use like a typical value. This value is relatively stable across countries and across time, it's been shown, at about, kind of 1/3, 2/3. So like 1/3 of national income goes to capital and 2/3 goes to labor. Right? So using like an alpha of around 0.33 or 0.36, somewhere around there is pretty standard. So we want to first download population data from the OECD historical population. Right? Okay, so let's use that. Just take it back as far as we can. Reference area, just going to go with Korea. We want population. We're going to want, okay. So I want the total, but I also want the working age population from 15 to 64 right here. Yeah, so that's all I need. Okay, so for Korea's case, we have data from 1950 onwards. We have total population as well as the working age population. Like I said, you can download this, right, and save it as either an Excel file or a CSV. But I want to check out the developer API. So it has here the address. So let's go ahead and compare this with what RStudio had predicted for us. Okay, not sure exactly what it got wrong, but I'm just going to delete that and we'll try it again. Okay, so that seems to have worked. We can check that over here. We saved it under OECD population. And so when we double click on this, it has, all this, we have the Korean data, we have population, we have, total, but also working age. And then we have these observation values. Okay, so it has the Korean data. Now, remember I showed you guys how to like download data for like all the countries and not just the Korean data? You can kind of experiment with that as well, okay? Now, we go on to the next stage. Okay, so we said load employment data from the OECD annual employment and population. So let me search for that on the OECD website. Okay, so we have annual population and employment national concept. Okay, so we'll go to time period, and this one starts in 1950. And here you can select all the countries. I just want to see if it has the data for Korea. And then here I'm going to want employment. Okay, the data for Korea starts in 1970. It's probably the case that for other countries it goes back further. So it has the total population data, and then it has the total employment. Okay. And then, like I said, you can hit download and download this in Excel or CSV file. I'm going to utilize this developer API feature. Okay, so that API worked. Okay, data raw OECD population.csv. Okay, so now that I've done that, I can go ahead and just like comment out. I can comment this out, And in the future, when I run this, instead of running the API approach multiple times, now that I've saved it as a CSV file, so now it's on my local hard drive, I don't need to use the API every time I run that portion of the code. And so I just need to read this one line. Same thing here. Once I have downloaded this OECD employment data, the Copilot is suggesting to me to save to the raw data. It gives me the command to write into a CSV file. I'm going to read from the data. Let me run this part so that it's written. And then the next time I run it, I just need to read it in from the CSV file that I've saved. So I can go ahead and just comment out these other parts. I'm going to read in this OECD population data set, and I'm going to take a look at it and see how it's structured again, right? So I don't need all this, but I do need, what I need is, so there's this measure, which just says population. And then here I have the age where there's total, and then there's also the working age population, okay? And then there's the time period and the observation value. So I need all of those things. So now coming back, I'm just gonna keep the stuff that I need, right? So up here, okay. So I've read in this OECD population data set. What am I gonna wanna do it? I wanna keep Korea, even though I only downloaded Korea, so this step is redundant, but I'm just gonna keep it there in case I decide to go back to the code and say I wanna download all the countries instead of just Korea, right? So I'm still gonna need this. Then I can rename some of these variables that I want. So instead of time period, I want year. Instead of observation, value, I have population, and I need to keep the age because this is what allows me to know whether this is total population or if it's working age population. And then I'm gonna select these, right? So here, I'm gonna select this and then save that as Korea population. Okay, so let's see how well Copilot understands. So change to wide data format. Let's see what it says. Korea population, and I'm just gonna, okay. Let's see what it says. Pivot wider. So names from age, values from population. I think that's exactly what I want. So let me try running that. Korea population wide. Okay, so that's exactly what I wanted. All right, so here, the original one had years and then population and then another column that has age, right? So instead, I've run this code, which now has transformed it into, basically, I have years only once. I don't have the years repeated, okay? So now I have the total population, and then I have the working age population. I just have to change the name of the variables to correspond to that. So that you can do, actually, you can just keep going here, and then do, okay, so rename total. So it's total, but I wanna keep this as like, just regular population. And then, yeah, so it says, working age population, but I'll probably just do like, yeah, that's fine. We'll just keep it as working age population, and then we know that the variable is from 15 to 64 years, right? Okay, so let's try this. So now when I look at Korea population wide, I have year, I have population, and then I have working age population, and then I have the years, because that's the way that I wanted to organize my data set. And so I'm going to do the same thing for the employment data as well, okay? So now I've opened the OECD employment data, so let's go see how that's structured, okay? So here, actually, all I need is the employment data. So transaction, yeah, total employment. I'm going to filter on the transaction being total employment. So I'm going to create a new data set called Korea employment. I'm going to use the OECD employment data set. I'm going to filter, I'm going to choose Korea. Again, this is redundant because I only have Korea, but when there's multiple countries, like I said, this will be useful. And then I'm going to use this filter on transaction equal total employment. And then I'm going to do the same here. I'm going to rename time period to year, and then I'll rename the observation value to employment. And then I just need these, I'm just selecting year and employment. So I open Korea employment. Now I have year, and then I have employment. Now, these units are different. I'm gonna want them to be comparable. So what I wanna do is I can mutate the employment. What I wanna do is I want to multiply this number by what was the variable? It was unit mult. So it needs to be 10 raised to the third power. 10 raised to the unit mult. So 10 raised to the unit multiplier. The unit multiplier is 3. It just means that you need to add 3 zeros, right? And this is the way to do it. So let's try that again. Okay, so now this is correct. So I have employment. These are the number of employed person in Korea in 1970. It's a little bit less than 10 million. Okay. Now that I've kind of organized the data set into the structure that I want to do, now let me merge the two data sets. And it's saying I should use this, so let's see what it does. So Korea labor. Okay, so I have year, I have population, I have working age population, I have employment, and I have these from 1970 to 2024. Okay, so this is the way I wanted the data, right? Okay. Now, used inner join, so you'll notice that I lost some data because some of my data went back to 1960 and some of them went to 1970. What inner join is doing is it's tossing out stuff that like the two data sets don't have in common. And then I have the outer join, but it's called left join, right join, and full join. And so I think instead of outer join, I should have called it full join. Let's see what happens when I do that. Okay, and now when I look at Korea labor, so now I've kept all the data that I lost when I do inner join. So these are some of these things that if you script into the editor, right? Like you want to give in Copilot more information, right? So like I'm not sure like I would have defaulted to tossing out all this data. So if I had said okay, merge the data but keep and don't toss out years, right? Then it would have chosen this as opposed to the inner join. So you just have to be aware of these things. Constantly just check your data to make sure that you haven't lost any data that you otherwise wouldn't have thrown away. So, but of course, I'm not going to be able to use much of this anyway because I need the employment data to be able to do the growth accounting. And so I'm eventually going to have to toss this out. But as far as I want to go as far as I can without having to toss out the data. All right. So this is what I have. I have data for the population data I have from 1950. The employment data I have from 1970 all the way to 2024. Okay. So now Copilot is suggesting that I merge with Korea capital data, which is a very good suggestion. I'm going to use full join and let's see what I get. So now let's look at Korea. It's a Korea data, Korea growth accounting here. So in Korea's case, the investment and the GDP data started in 1960. But because I used full join, I'm keeping all the years that I have, population and other years, right? So I have the capital stock, I have GDP, I have population, working age population, and employment from 1970 onwards. Okay, so for maybe here it does make sense to do the inner join because I don't need the years actually to do the growth accounting. I don't need the years that I don't have all the data for. So I'm going to go ahead and use this inner join instead. Okay, so now I have data from 1960. Okay. So now I can calculate GDP per working age person according to that formula that I showed you guys in the slides, right? So this is the way to do it. So here I have, instead of calling this YPOP, I'm going to call this GDP, which is just real gross domestic product per working age person. So here I'm going to do our GDP divided by working age population. So that's good. Then I have the A factor. I'm going to comment this out for a minute. And then we can go back to our PowerPoint slide. We have output per working age person. We have the TFP term. And then we have capital to output raised to the alpha over 1 minus alpha. So here, when we go back to our R code, we have capital over output raised to the alpha over 1 minus alpha. And you know how Copilot knew to do this, to do it this way? Because there's many ways you can decompose GDP per working age person. I wrote it into the script. I said, decompose or calculate GDP per working age person, and then calculate the capital output factor, and I specified exactly, that formula. So if you provide the right script, Copilot will do most everything for you. Okay, and then I have the employment factor here. I'm going to call this like capital factor and employment factor. And I'll call this real GDP underscore working age person. Okay, and then once I have these, so in fact, this TFP term is just working age, GDP per working age person divided by the capital factor divided by the employment factor, right? So I'm just going to use that formula here. Productivity factor, okay, it read my mind. So productivity factor is calculated by taking real GDP per working age person, dividing it by the multiple of the capital factor and the employment factor. Right. that seem to have worked. And so, of course, for the years that I don't have employment, I can't compute the employment factor. And for those years, I don't have the productivity factor as well. Okay, so let me change the script a little bit to say, keep keep only years that I have, that all are non-missing. Okay, so it's gonna think a little bit, and then it's gonna suggest that I do drop NA. All right, so let's run that. And now when I open up Korea Growth Accounting, it has from 1970 onwards, because that's, remember, for employment, I didn't have anything going back before that. So now when I go and look at the decomposition, I have all the data for the capital factor, the employment factor, and the productivity factor. Okay, all right. So, and then the rest is really easy now. I have the growth accounting, and so now I'm gonna index the levels to 100 in the first year. So what it's gonna do is say, okay, start year is the minimum year which I have, and it's going to read off 1970, right? So if I run this part of the code, right now I don't have a variable called start year, but when I run this start year, it's going to say it's 1970 L. So that L just means that this is an integer, and then I'm going to want to say growth accounting, Korea growth accounting indexed. So it's going to mutate the real GDP into the index. So the way it does that, it's going to create a new variable, RGDP WAP index. It's going to take the real GDP per working age person variable that we have, and then it's going to divide it by the real GDP per working age person of the start year, which is 1970. So take the GDP number, divide it by the GDP in 1970, and then multiply it by 100. This is going to guarantee that in the year 1970, it starts at 100, and then, if it grew by 2% the next year, it's going to be 102, and then 105, and then 110. And then it's going to do this for all the variables, the capital factor, the employment factor, and the productivity factor index. Okay, so I like what I see there, so I'm going to run that. And when I look at Korea Growth Accounting indexed, now I have these indexed variables as well. I have the RGDP per working age person index, the capital factor index, the employment factor index, and the productivity factor index, and these all start at 100. And for the variables that grow, these numbers are increasing over time, which is what I expected. Okay, so now let's plot the indexed levels. I want to do ggplot, and it shows like it's suggesting a bunch of stuff. Let's go line by line to see if we're going to accept all of these things. So it's using the ggplot like it should, and I'm using the Korea Growth Accounting Index data set. And on the x-axis, I want to put years. Of course, it's the time series. So that's what I want to do. The geom line is, I want a time series. It's a line plot. And I'm going to plot the GDP index, the capital index, the employment index, and the productivity index. Okay, so let me just do something very simple, which is, okay, instead of this fancy way of setting the color, let me just change this directly to, just say black. I think I need to do quotations, black. Yeah. And then capital blue, and then this will be green, and this will be red. Okay, and I'm gonna get rid of some of these things for now. All right, so let's try. All right, because I don't have the legend, I don't know which line is what. Based on what I know about the Korean data, is that the black line is the GDP per working age person. The red line is the productivity term. Korea's been roughly on a balanced growth path from like 2000 onwards, like roughly growing at a constant 2% per year. But of course in the 70s and 80s and 90s, it was growing very fast. So it's not on a balanced growth path yet. When we look at these two other lines, which correspond to the capital to output factor and the employment factor, those are pretty flat. Now, I do want to see if I can make sense of some of these other ones to get it to work. So theme, legend position equal none. That's consistent with what I want. Now I need to be able to put these labels in the right spots. And let me see, if I just follow the steps that it has suggested, is it gonna work? Let's see. Okay, it did something. Okay, that's not too bad. Now, I think the employment factor looks nice. It's right under the green line. The capital factor is right above the blue line, productivity. The only thing that's not so nice is the GDP per working age person, that label, because it's going outside of the graph. So you want to bring it down a little bit, and you want to move it to the left a little bit. So when you go to the geom text here, it's putting this label GDP per working age person right where the value of the index is for that year. And H just is adjusting stuff right and left, and then vertical just is doing the same thing. So I'm just going to go ahead and say, okay, what if I just remove that minus sign there? Let's just see where it puts it. Because before it was up too much, and now let's see if that has been fixed. I think it has. Okay, so I am going to do the same adjustment on the H just as well. I'm going to want to, here it says 1, and larger numbers are going to move it to the left. So let's see what happens if I put 1.5 there, because I want to move it to the left a little bit. I mean, that's not too bad. I'm happy with that. I think probably I just needed 1.2 or 1.3, and that's fine. So, you would save this as a PDF, and this is what you would submit for that part of the problem set. Okay. Now, I do want to see how well it does now that it understands that this is the way I want the graph to be done. Now when I get down here, now alternatively, I have a script here that says use log scale for y-axis labels. My hope is when I get there and it's going to suggest something, I can just run it. I don't have to modify anything anymore because I've provided not any details in the script, but above I've edited the code to my liking. So hopefully it understands how I want it to be done. So let's see, waiting for completions. Okay, so let's see. Accept those suggestions, and now let's run it. So compared to what I had before, it's almost exactly the same. Where it is? Okay, but it added in line 234, there's a scale y log 10. So this is what's changing it to a log scale. So what happens now when I run this? Okay, so this is now in log scale. I'm probably gonna wanna mess a little bit with where the labels go so that the label for employment factor is not sitting directly on top of the line. So I'm gonna probably wanna shift it down a little bit. But other than that, it looks good. Now, how does this look different than the linear scale? So look at the scales now. So you're kind of zooming into these lower numbers a little bit. So now you can see that before all you could see was that GDP was growing really fast, and then productivity was doing most of the work, and then the other lines were kind of flat. You couldn't see which one was rising or not. Here you can see that both, in fact, the capital factor and the employment factor are also rising, but of course they're not rising as much as the productivity factor, and that's okay. And so once you've done this for a number of different countries, and if you program in R, it's very easy to look at other countries' growth accounting as well, and you can look at them side by side. Then you get a sense of, okay, Korea is a country compared to 1970 where there has been capital deepening, meaning that there's, some of the growth in part has come from the fact that there's more capital in the economy. Some has come from the fact that there's more people working as a fraction of the overall population. And then, a lot of the growth in Korea has come from growth in TFP. So not every country looks like this. And so this is a very useful tool to have. Okay, all right.